Welcome, tech enthusiasts, to the Operating Systems Crashcast. I'm your host, Victor, and I'm thrilled to kick off our very first episode of Season 1, Overview. Today, we're diving into Chapter 1, Introduction, and specifically, we'll be exploring Section 1.1, What Operating Systems Do. Joining me is my brilliant co-host, Sheila. Say hello to our listeners, Sheila.
Hello, everyone. I'm excited to be here with Victor to unravel the mysteries of operating systems. As this is our first episode, we'll be setting the foundation for understanding these complex but fascinating pieces of software that run our digital lives.
Absolutely, Sheila. Before we dive in, let's give our listeners a quick overview of what to expect this season. We'll be covering the basics of operating systems, from their core functions to their structure, and even touching on some advanced topics like process management and security. Today's episode is the perfect starting point for our journey.
That's right, Victor. And for those of you who might be wondering why we're starting with such a fundamental topic, remember that understanding the basics is crucial for grasping more complex concepts later on. Now, shall we jump into our quiz question for the day?
Great idea! Here's today's quiz question for our listeners. What are the two main purposes of an operating system? Keep this question in mind as we go through the episode, and we'll reveal the answer at the end. Now, Sheila, let's start with the fundamentals. How would you define an operating system?
That's a great place to start, Victor. At its core, an operating system is a software that acts as an intermediary between computer hardware and the user. It's like a conductor in an orchestra, coordinating all the different components of a computer system to work harmoniously together. The OS manages the computer's resources, provides services for programs, and offers a user interface for interaction.
Excellent analogy, Sheila. To build on that, let's break down the components of a computer system that an OS interacts with. We have the hardware, which includes the CPU, memory, and I/O devices. Then we have the application programs like web browsers or word processors. The operating system sits between these two layers. Can you elaborate on why this positioning is important?
Certainly, Victor. The OS's position between hardware and software is crucial because it allows for abstraction. This means that programmers and users don't need to know the intricate details of the hardware to use the computer effectively. The OS provides a uniform and simplified interface to the complex underlying hardware. This abstraction is one of the key reasons why we can run the same software on different types of computers with different hardware configurations.
That's a great point about abstraction, Sheila. It reminds me of how we don't need to know the inner workings of a car engine to drive a car. The car's interface, the steering wheel, pedals, and dashboard, abstracts away the complexity. Similarly, the OS provides an interface that simplifies our interaction with the computer. Now, let's dive deeper into the main functions of an operating system. What would you say is the primary role of an OS?
The primary role of an operating system, Victor, is resource management. Think of the OS as a highly efficient office manager. Just as an office manager allocates tasks, manages schedules, and ensures that resources are used effectively, an OS does the same for a computer's resources. It manages the CPU time, memory space, file storage, I/O devices, and in many cases, even network resources. This management ensures that multiple programs can run simultaneously without interfering with each other.
That's a spot-on comparison, Sheila. Let's break down some of these resource management tasks. For CPU management, the OS decides which processes get to use the CPU and for how long. In memory management, it allocates and deallocates memory space as needed by different programs. For storage management, it keeps track of where information is stored and who has access to it. Can you think of any real-world implications of this resource management?
Absolutely, Victor. The implications are everywhere in our daily digital lives. When you're browsing the web while listening to music and perhaps running a virus scan in the background, it's the OS that's ensuring each of these tasks gets the resources it needs without crashing your system. In a larger context, efficient resource management by operating systems is crucial in data centers that power cloud computing services. ensuring that millions of users can access services simultaneously.
Excellent examples, Sheila. Now, let's shift gears a bit and talk about the user perspective. How does an operating system present itself to the user, and why is this important?
From a user's perspective, Victor, the operating system presents itself primarily through the user interface. This can be a command line interface, CLI, or a graphical user interface, GUI. The interface is crucial because it's how users interact with the computer system. A well-designed interface makes the computer more accessible and user-friendly. For instance, the desktop metaphor used in many GUIs with icons representing files and folders makes it intuitive for users to navigate their computer's contents.
That's a great point about interfaces, Sheila. It's interesting to note that while most personal computer users today are familiar with GUIs, command-line interfaces are still widely used, especially in server environments and by power users. This brings us to an important aspect of operating systems: their flexibility in catering to different user needs. Can you elaborate on how operating systems serve different types of users?
Certainly, Victor. Operating systems are designed to cater to a wide range of users, from casual home users to system administrators and developers. For home users, the OS provides a simple, intuitive interface for tasks like web browsing, document creation, and media playback. For power users and system administrators, it offers advanced tools for system configuration, network management, and performance monitoring. For developers, the OS provides APIs, or application programming interfaces, which are sets of tools and protocols that allow them to create applications that can interact with the system resources.
Excellent breakdown, Sheila. Now let's delve into a bit of history. Can you give our listeners a brief overview of how operating systems have evolved over time?
Of course, Victor. The history of operating systems is fascinating and closely tied to the evolution of computer hardware. In the early days of computing in the 1950s and 60s, computers didn't have operating systems as we know them today. Each program had to include code for controlling the hardware. The first operating systems were developed to automate the setup and sequencing of programs, saving time between runs. As computers became more powerful and complex, operating systems evolved to manage multiple programs running simultaneously, multitasking, support multiple users, time-sharing systems, and provide more sophisticated user interfaces. The personal computer revolution in the 1980s brought operating systems like MS-DOS and the early versions of Windows and Mac OS to home users. Today, we have a diverse ecosystem of operating systems for various devices, from powerful servers to smartphones.
That's a great historical perspective, Sheila. It really highlights how operating systems have become increasingly complex and capable over time. Now, as we near the end of our episode, let's touch on a concept that ties everything together: hardware abstraction. Why is this such a crucial function of operating systems?
Hardware abstraction is indeed a key function of operating systems, Victor. It's the process by which the OS hides the complexity and differences of hardware devices from applications and users. This abstraction provides a consistent interface for software developers, regardless of the specific hardware the software will run on. For example, when a program needs to write data to disk, it doesn't need to know the specifics of the hard drive or SSD. It just uses a standard set of commands provided by the OS. This abstraction not only simplifies software development, but also enhances portability, allowing the same software to run on different hardware configurations with minimal modification.
Excellent explanation, Sheila. As we wrap up, let's recap the key points we've covered about what operating systems do. 1. Operating systems act as intermediaries between hardware and users' applications. 2. They manage computer resources like CPU, memory storage, and I/O devices. 3. OS provide user interfaces, both graphical and command line, for interaction. 4. They cater to various user needs, from casual users to developers. 5. OS have evolved significantly over time, becoming more complex and capable. 6. They provide hardware abstraction, simplifying software development and enhancing portability. Now, Sheila, would you like to answer our quiz question from the beginning of the episode?
Absolutely, Victor. The quiz question was, What are the two main purposes of an operating system? Based on our discussion, we can say that the two main purposes are 1. To manage computer resources efficiently. 2. To provide a user interface for interaction with the computer system. These two purposes encompass the role of the OS as both a resource manager and a user-friendly intermediary between hardware and software.
Excellent answer, Sheila. That wraps up our first episode of the Operating Systems Crashcast. We hope our listeners found this introduction to what operating systems do informative and engaging. Join us next time as we delve deeper into the world of operating systems. Don't forget to subscribe to catch all our upcoming episodes. Until then, keep your systems running smoothly.
Thanks for listening, everyone. We're excited to continue this journey through the fascinating world of operating systems with you. See you in the next episode.